Hi friends, this is Prince Kamal Kiran, Assistant Professor, Civil Engineering Department. I welcome you all to Witsconnect. Okay, today we are going to discuss about RCC. What do you mean by RCC? RCC means reinforced cement concrete. Why we call a reinforced cement concrete? Let us go into the subject and discuss about that one. And you all know concrete. Concrete is a material which is used in the construction of slabs, beams, footings and all the structural members, and the concrete is manufactured by using of cement, fine aggregate, coarse aggregate, water and admixtures, and these are obtained from different resources. Okay, now what is the purpose of providing the reinforcement in the concrete members? Okay, now let us see. The concrete which is manufactured after attaining its final strength, what happens is a concrete is good in compression and weak in tension. When compressive forces are acting on the concrete, it can withstand, but when the tensile forces are acting, the concrete may get failed. Let us see, for example, if it is a concrete block, I am applying the load on the two opposite faces of the concrete block. What happens is it can resist to some extent and no deformation occurs. But when you go for a beam, here the supports are there. Now due to the action of load on the beam, what happens? Deflection occurs like this, and there might be chances of failure. And now we can say that concrete is good in compression, weak in tension. So what happens to make the concrete support the tension or to withstand the tension loads? What happens is we are going to provide the reinforcement in the tension member. For example, this is a beam of breadth B and depth D. Here what happens is this is the neutral axis. The bottom part is called as tension member and the upper part is called as compression member. Here the loads are acting on from the top surface. What happens? Due to the action of load, deformation occurs, and due to tension, the deformation, the beam may be collapsed. So to avoid that one, we are going to provide reinforcement in the tension member. Now let us discuss what are the different types of concretes. First one is the plain concrete and second one is the reinforced concrete. What do you mean by plain concrete? A plain concrete, in the plain concrete we find fine aggregate, coarse aggregates, cement, water and admixtures are used in the manufacturing of plain concrete. And in the plain concrete, no reinforcement is provided. But coming to the reinforced concrete, in reinforced concrete, in addition to all these materials, steel is also used as a reinforcing material. When steel is introduced in the concrete members, then we call it as a reinforced concrete member. Now, why do we provide steel? What is the purpose of providing steel? Why we cannot use other materials which are other metals which are available in the market? For example, we are having different types of metals like steel, gold, titanium, platinum, aluminum. Different materials are available in the market, and we cannot provide all these materials for the purpose of reinforcement, but we can only provide iron as a reinforcement. Why we provide iron as a reinforcement? For example, what is the reason of providing iron as reinforcement? And let us discuss about that one. Now let us go with another new topic, coefficient of thermal expansion. Coefficient of thermal expansion. What do you mean by coefficient of thermal expansion? Due to the changes in environmental conditions, that means due to varying weather conditions, there might be deformation in the bodies. Expansion, contraction occurs, and due to that one, the size of the concrete member or the metals which we are going to be used will deform, Due to that, the length, width and the dimensions are going to be changed. So expansions and contractions are going to occur. So what happens due to that one, the two materials which we are using as reinforcement, which we are going to use, should have the same coefficient of thermal expansion. So that if these two materials are having the same value of coefficient of thermal expansion, then automatically the structure can withstand. Why? Because the coefficient of thermal expansion of steel and concrete is same. Due to that one, the coefficient of expansion will be uniform for both the materials. So due to that one, what happens? No deformation occurs, no losing of joints or bonding nature between these two materials will not be changed. If we are going to use other materials of different coefficient of thermal expansion, what happens is, for example, gold will expand more length than the concrete or something else. Due to that one, deformation occurs, cracks are developed and the bonding between the concrete and the material will be decreased. So the structure cannot withstand. So for that purpose, we are using steel as a reinforcing material. Now, what are the different structural members in which we are going to use the reinforcement? Here, these are the different members in which we are going to, in this subject we are going to deal with these different structural members. In that first one, footings, columns, beams and slabs. And this you all know, footing is the bottom part of a building, and then after columns are raised from the footings, and then after beams and slabs are casted. Okay, now what happens is, here when we construct a building or a structure, what happens? Load is going to be applied on the slab, and this slab transfers the load to beams, and these beams and slabs transfer to columns, and that one to footings, and next to the ground. Here each and every member plays its own role. First is slabs. These provide access for usage for walking, and it provides shade from other natural effects. And the next one, beams, which provide support to the slabs, and columns also provide the support to the slabs and beams, and footings will rest the structure on the ground, and then after the load is transferred to the ground surface. What happens is, here due to the action of load, that means slab load is acting on the beams and beams load is acting on the columns, columns to footing, footings to the ground. Each and every member should resist the load acting on them. So to know how much load is acting on a member and how much reinforcement is required for a structural member to withstand these loads, we can know, or we can design those structural members in this subject, reinforced cement concrete, RCC. In this we are going to design all this, how much amount of steel is required, how much quantity of concrete is required, and what is the mix design required depending upon the loading conditions, and all those things we are going to design these structural members. And here in our first class, what we are going to discuss is about the beams. Now let us discuss about the beams. These beams are the horizontal members which are supported by the columns and which support the slabs. And coming to the types of beams, there are two different types of beams. First one is the singly reinforced beam, second one is the doubly reinforced beam. What do you mean by singly reinforced beam and what do you mean by doubly reinforced beam? And here, coming to the singly reinforced beam, a singly reinforced beam is nothing but where the reinforcement is only provided in the tension member. When the reinforcement is provided in the tension member only, then it is called as singly reinforced beam. If the reinforcement is provided in the tension member as well as in the compression member, then it is called as doubly reinforced beam. Once I am repeating, what do you mean by singly reinforced and doubly reinforced means, when we provide reinforcement only in the tension member, then it is called as singly reinforced beam. When we provide it in the compression member, it is called as doubly reinforced beams. And we are going to provide the reinforcement in the tension members and as well as in the compression members. And here what happens is, at the supports, after providing the longitudinal bars like this, what happens is, due to the bending moment, cracks are developed in the center of the beam as well as at the supports of the beam. And here at the center, vertical cracks are developed like this, and at the supports where the beam is joining with the columns, here cracks with an angle of 45 degrees are developed. And to avoid that one, to avoid or to stop the development of cracks in those, these cracks are called as shear cracks, and to avoid that one, we are going to provide the shear reinforcement. What do you mean by the shear reinforcement means? For example, here this is a beam, we are going to provide the longitudinal bars like this, and afterwards we are going to provide the bars like this. We call these bars as stirrups, and these stirrups are provided to avoid the shear failure. And here these stirrups, these shear reinforcement is called as stirrups. And here, coming to the stirrups, we are going to provide three different types of stirrups. First one is the vertical, second one is the inclined, and third one is the cranked or bent up bars. Here, this is in this diagram you can see the vertical stirrups, and coming to the inclined stirrups like this, it is like this, we are going to provide like this. And coming to the bent up bars, we are going to provide the bent up bars like this in the middle of the beam. And we do not use these inclined stirrups. Why? Because the pouring of concrete in these one and arrangement of the inclined stirrups is somewhat hard. So due to that one, we do not use inclined one, and we go for the vertical stirrups and cranked or bent up bars. These are used as shear reinforcement. And next we are going in what are the different methods adopted in the design of these beams, slabs and all the structural members. We are going to discuss in our next class. And here another important thing is the code which we are going to use for designing purpose is IS 456 2000. This is the code book which we are going to use for the design of reinforced concrete members, and this one is given by the BIS, Bureau of Indian Standards, and by using of that one we are going to design the concrete members. Thank you.